I'm going to write equations from which I can find I for this circuit in two different ways. First, I'm going to use constrained loops, and then the next time through I will avoid constrained loops. If I use constrained loops, I kill the current sources and the voltage sources. This becomes a short circuit. The current sources become open circuits. There's only one remaining enclosed non-overlapping area at that point. It's up here. So the constrained loop is going to go around the perimeter of that enclosed area. I'm going to call that mesh current I1, and it's going to go this direction through here. Now I'm going to define constrained loops that will account for the currents through the current sources. This is a 2 amp current source. It's going positive in this direction, so I'm going to create a constrained loop that's got a 2 amp current going this direction. It matches the magnitude and direction of the current in that current source. I also have a 2 amp current source over here that's positive in this direction. I'll create a constrained loop that goes around this way and matches the magnitude and direction of the current on this current source. So it's going in this direction. It's got an amplitude of 2 amps. So with this approach, we have only one unknown, that's I1. So let's do KVL around a loop that follows I1. If I start down here, I see the 1 ohm resistor first. Its voltage is its resistance, 1 ohm, times the sum of the mesh currents going through that element. The only current going through that element is I1. I'll set up my sign convention such that I1 enters the positive voltage terminal, so that will become just I1. Next, we encounter this 2 ohm resistor. Again, I'll set my sign convention such that I1 enters the positive terminal. The voltage difference is then 2 ohms times the sum of the currents going through that. The first will be I1. It enters the positive terminal, so that's a positive contribution. And this 2 amp constrained current also enters the positive terminal, so that's a plus 2 amps. Now continuing around, I see the positive terminal on the 8 volt source next, so that becomes a positive 8 volts. That brings me back to my starting point, so that sums up to 0. So I have one equation and one unknown that I can solve for I1. Now I just need an equation for the current I in terms of I1. I is the current through the 1 ohm resistor, with positive being in this direction. The only mesh current going through the 1 ohm resistor is I1. It's in the opposite direction as I, so I is just the negative of I1. Now let's do the problem again without using constraint loops. If I don't use constraint loops, I have mesh currents that go around the perimeter of every single enclosed non-overlapping area in the circuit. So this will be a mesh current. I'll call that I1. This down here will be a mesh current. I'll call that I2. And this will be a mesh current that I'll call I3. Now I need to account for the unknown voltages across the current sources. I'll arbitrarily choose this as V sub x with an arbitrary sign convention across this 2 amp source. And I'll assume that this is a different voltage V sub y with that arbitrary polarity across this current source. Now I've got 5 unknowns, 3 mesh currents, and 2 unknown voltages. I'll need to write 5 equations to solve for those. After I do that, I can write an equation for the current I. If I follow loop I1, if I start down here and follow that direction, I have a voltage across the 2 ohm resistor that's 2 ohms times I1. And then I encounter the positive terminal on V sub x, so I add V sub x. That brings me back to my starting point, so that sums to 0. Loop I2, if I start down here in this lower left-hand corner, I see the 1 ohm resistor. The voltage across the 1 ohm resistor is its resistance times the sum of the mesh currents, which is just I2. Now I see the negative terminal on V sub x next, so I subtract off V sub x. Coming around here, I see the positive terminal on the 8 volt source, so I add 8 volts. That sums to 0. Mesh current I3. If I start down here at the lower center part of the schematic, I see the negative terminal on the 8 volt source first, minus 8 volts. Then I'm coming around here. The voltage difference across the 3 ohm resistor is that resistance times the sum of the currents, which is 3 ohms times I3. Coming around here, I see the positive terminal on v sub y next. I add that. That brings me back to my starting point. I have 3 equations in 5 unknowns at the moment. I need 2 more equations. Those will come from my constraints. From this 2 amp source up here, there's 2 amps going from right to left through this source. So 2 amps is going to be the sum of the mesh currents, which is I1 minus I2. The other current source has a 2 amp current going from top to bottom. That's in the same direction as I3, so I3 has to be equal to 2 amps. That gives me 5 equations in 5 unknowns that I can solve for the mesh currents. Now I write an equation for I in terms of the mesh currents. I is through the 1 ohm resistor, positive in this direction. The mesh current through that resistor is only I2, but it's going in the opposite direction, so I is equal to the negative of I2. There's a set of equations I can solve for the current capital I.